So in the next few examples, we're just going to practice our skills, and the next three are just about doing the equation style, which was the first style that we did, because usually that's where people need the most help in practicing for finding an inverse. So step number 1 in number 4, I'm going to switch the x and the y. So instead of being y equals 4th root of 6x, I'm going to go with x equals the 4th root of 6y. And now I look at that and I'm like, oh man, I got that root thing in there and I don't want it there. So when we have a square root of something, to undo the square root, we square it. We raise it to the power that's the same as the root. In order to get rid of a 4th root, same kind of idea, we're going to raise both sides to the 4th power. And the reason we're doing that is a 4th root and a 4th exponent are inverses of each other. They undo each other. So now I have x to the 4th on the left, and the 4 for the power in the blue and the 4 for the root in red cancel each other out or undo each other. And that gives me just 6y. And all I have left to do now is to divide both sides by 6, and I'm finished. So I divide both sides by 6, and I've gotten my y alone. So my answer is, I probably should do it so you can see it the way it looks. I've got my answer of x to the 4th all over 6 equals y. This is my inverse. Don't forget that you could write this y if you want to as f inverse of x. And when you get to a more advanced level of mathematics, they'll probably ask you to always write it that way to indicate that you found the inverse. So be comfortable with that. It's just another notation. In example number 5, same kind of idea. Step number 1, we're going to switch the x and the y's first. So I have x equals parentheses y minus 2 parentheses squared minus 5. So step 1, always switch the x and the y when you're finding the inverse. And now I have to get to the y thing. So I always work from the outside all the way to the inside. To get rid of that minus 5, I'm going to add 5 to both sides. So add 5 to the right to get rid of that 5, add 5 to the left. When I get done with that, on the left side I'll have x plus 5, and on the right side the 5's are gone now, and I have parentheses y minus 2 parentheses squared. And similar to the problem in number 4 where we had a root and we undid it with a power, now we have a power and we're going to undo it with a root. So I'm going to square root both sides. Square root the right hand side to get rid of that 2 for the power, square root the left hand side to get rid of that root. Don't forget that if you square root a variable, you always have to go with a plus or minus. So currently, after I do that, I will now have plus or minus the square root of x plus 5 equals y minus 2. So we undid the squaring with a square root, but since the square root covered a variable, you have to put plus or minus, because you could get a positive answer out or a negative answer out. And then the last thing to do is to move that 2 to the other side by adding 2. And so I would have y is equal to that positive 2 plus or minus the square root of x plus 5. Now if you wanted to, of course, you could have written down plus or minus square root of x plus 5, and then after that, so after this square root ends, you could have plus 2 more. So I don't really care which way you write it. I usually put the number out in the front so I don't get confused that it's underneath the radical. That's just the way I like to write it. It makes it less confusing for me. In number 6, seems like to me, I don't know why they put this one last in this group. Seems a little bit easier than the last one. In number 6, I'm multiplying by a half. So the way that you would undo multiplication by half is you'd multiply by 2. But before I can do any of that, I have to switch the y and the x. Very good. Switch the x and the y. So now I have x equals 1/2 parentheses y minus 4. So step 1 is always switch the x and the y. And to get rid of the multiplication by a half, you're going to multiply both sides by 2. Because 2 times 1/2 is 1. That's why we're doing it. And so on the left side now, I'm going to have a 2x. And on the right side, because the 2 and the 1/2, when you multiply them, just give you 1, you don't really need the parentheses anymore. So I'm just going to write down y minus 4. And how do you undo that minus 4? Add 4 to both sides. So if I add 4 to both sides, the 4 on the right will be gone, and I end up with 2x plus 4 equals y. So that one seemed a little bit easier than the previous one. I don't know why, but it did. In this last problem, they throw us one extra piece that we're supposed to do. And so at the very end, we're going to do something called finding the composition. And I'll show you how to do that. So the first part is finding the inverse. So let's start with finding the inverse, and then we'll go and I'll show you what this composition thing means. So first of all, I don't really like to see f of x. I don't know why, but it's easier for me to think about it when I see y equals 4 minus 3x. Because I always know that step number 1 is switch the x and the y. So now I switch that x and the y, and I have x equals 4 minus 3y. And then I have to get that y thing alone, so I'm going to move the 4 to the left-hand side, and the way I do that is I'm going to subtract off 4 from both sides. And the point of doing that is that the 4's will cancel out. So on the right-hand side, I get negative 3y. And on the left-hand side, the x and the minus 4 don't go together, so I just write them down, x minus 4. And the y is almost alone now. The only thing I have left to do is to write down divided by 3. So if I'm looking for my inverse, my final answer for my inverse piece of this is that my inverse is x minus 4 over negative 3. That's the inverse that I found. Now in the composition of functions, what they want you to do is they want you to throw in the inverse into where you see the x. That's what they want you to do. So what I'm getting at there is they want you to take this stuff and shove it in right there. That's what they mean by composition of functions, with the function and its inverse. If I do that, here's what happens. I write down my original equation. So 4 minus 3 times whatever the inverse was. And the inverse that we found was x minus 4 all over negative 3. So I took what I found and I put it in for the x right there. And now, hopefully what you notice, and what they want you to notice, is that these negative 3's reduce out. So really what ends up happening is I've got 4, and then there's an x there, and there's no minus sign anymore because the negative 3 and the negative 3 cancel, so it's a positive x. And then a minus 4. And now you probably see that your 4 and your negative 4 cancel, and your final answer is just x. And kind of the interesting thing is, this does this every time. You will always find that it's x, no matter what's going on, no matter what the original was. It'll always be x if it's the inverse, because when you know what inverse means, switch x and y, that means that your y value, f of x, the y value, y, equals x. You switch them, x and y.